My name is Pablo Johnson, and I'm representing Team 1, the Troclosure team. Our team consists of 2 students from the College of Engineering, Spencer Madsen and Mike Fogarty, and myself from the School of Medicine. Dr. John Langell is our physician faculty advisor. Our device is used for laparoscopic surgery to create, but more importantly, to close the holes created by these ports, which is difficult to do and prone to complications like herniation. Our device does this by precisely placing the suture in the optimum place to ensure perfect wound closure. There's more than 2.5 million of these surgeries done in the U.S. each year, and each one a trocar is used to insert the port. It's then removed, but at the end of the surgery, that porthole has to be closed on both the inside and outside. It's the inside that's difficult to do and time-consuming. Also, it exposes the surgeon to the risk of needle sticks because they have to slide a needle really close to their finger. And there is a 2.3% port site herniation rate. That leads to wound complications and can even lead to revision surgery. The trocar market in the U.S. is over $300 million and is controlled by 3 major device manufacturers. The wound closure device is more than $200 million. Now, our device will capture both of these because it does both jobs for a market of more than $500 million. Our value to the patient will be faster recovery times and fewer complications. For the surgeon, it'll increase their safety, it'll reduce their OR times, and it should reduce their herniation rate. The hospitals save OR time and costs associated with surgeon needle sticks. Also, they can buy fewer devices because ours does 2 jobs. Hospitals right now are paying more than $100 for wound closure devices and an average of $44 for trocars. We're going to sell ours for $100, which is a healthy profit margin over manufacturing costs of $15 to $18. And we plan to start with regional distribution. But we've applied for domestic patent rights, and at the end of the month we'll apply for international patent rights so we can pursue a licensing agreement with some of these big companies. Let me show you how it works. The trocar is used to insert the port at the beginning of the surgery, and then it's removed. At the end of the surgery, you put it back in, and you align it properly, pull the handle out, and then when you push the handle back in, it deploys these absorbable anchors and sutures. And when you remove it, suture feeds out from the trocar, which allows the surgeon to knot it and then properly close the wound. For feasibility, we have working prototypes right now, which have been designed for injection molding and they're production ready. Our FDA specialist has said that this is a Class 2 device. It will go through the 510(k) pathway, and we started designing animal trials. So far, we've raised $85,000 to further this project. We remain dedicated to getting this product to the market and becoming the first bench-to-bedside team to truly go to the bedside.